In this video, we're going to complete example 5, and we're going to use something called the unitary method to solve some problems. Now, the two problems we're looking at involve percentages. This method, called the unitary method, is really useful in situations where you have quite complex questions involving percentages. And you'll notice that when we go through question B, that this question is probably more complex than you might think. Now, before we get into the example, I need to revise some concepts involving percentages, decimals, and fractions. I'm going to do two things. I'm going to start by explaining the relationship between percentages, decimals, and fractions. And then I'm going to show you how to convert between percentages, decimals, and fractions. Now, a lot of the people that are watching this video probably already know how to do these things. So you're more than welcome to skip ahead to the end of the video where I take you through the example. For those of you who struggle a little bit with percentages, decimals, and fractions, I'd like to encourage you to watch the whole video. We need to revise our knowledge of percentages, decimals, and fractions. And the first thing we're going to talk about is, why do we teach these three together? Well, to be quite honest, percentages, decimals, and fractions are basically the same thing. They're just written in a different way. So let's take, for example, the fraction 1/2. We can write that as 1/2. We can write it as a percentage, 50%. Or we can write it as a decimal, 0.5. So if these three basically all represent the same thing, why is it that we need three different methods to express the same thing? It seems counterproductive, right? Well, each method actually has its place. For example, percentages are really good at making something more visual. And I'll give you an example of that. When you go to shops, you'll see things such as 50% off. They put these signs up, 50% off or 25% off. All right? You never see them use a decimal. They never say 0.5 off, do they? They never do that, because decimals aren't really useful in a visual manner. They don't look really great on a sign at a shop, but percentages, they look great. Fractions also look pretty good at shops, so they can be quite visual as well. You've probably gone to a shop and seen a sign that says half price. The problem with fractions are that we generally only use the half price, the half fraction. We don't usually see quarter price or 3/4 of the price. But percentages, they love percentages. So if everyone loves percentages so much, why don't we just use percentages? Why don't we just get rid of fractions and get rid of the decimals? Well, there's one thing that percentages are actually not good at doing, and that's making calculations. Let's say I wanted to find 25% of a price. I wanted to find 25% of $200. Now, if I was to write this as a decimal, it would look more like this. It would look like 0.25 of $200. Or if I was to write it as a fraction, it would look like this, 1/4 of $200. So let's bring up the calculator and make these calculations. It's really easy to find 0.25 of $200. Look at this, 0.25 times 200. And I get 50. Really easy to do with a decimal. That's $50. It's also quite easy to do it with a fraction, 1/4 or 1/4. Let's clear this. 1 ABC4 times 200. That's also $50. So decimals and fractions are great for making calculations. What if I use the percentage, 25% of 200? Well, there isn't a percentage button. And if I did 25 times 200, 25 times 200, I'll get the wrong thing. I'll get 5,000. Now, some of you might be saying, I've actually seen a calculator with a percentage button. In fact, I've just found one here on the internet. This is a calculator with the percentage button. So we can type 25% times 200, right? Well, look what happens when I do that. 25%. Whoa, what's happened here? It's just converted it to a decimal. It's converted it to 0.25. So all that button does is take the 25% and convert it to a decimal. And why do they do that? Well, it's quite simple, to be honest. As I said before, decimals are good for making calculations, but not percentages. Anyway, we still have an example that we need to do, and there's one more thing I need to show you before we get into the example. I need to show you how to convert between percentages, fractions, decimals, and back to percentages again. So let's start with a percentage. Let's say we had 13%. And I wanted to convert that to a fraction. It's really easy because the word percent basically means out of 100. So 13% is the same as 13 over 100. Really simple to convert from a percentage to a fraction. To find the decimal is also really easy. All you need to do is look at the fraction, which is 13 over 100. Now, when you have a fraction, you can actually treat it as division. I can just go 13 divide 100, and I get 0.13. Now, a lot of people know how to convert straight from a percentage to a decimal simply by moving the decimal point to the left twice. That's another method as well. And finally, when we want to go from a decimal back to a percentage, what do? Well, we divided by 100 to get to 0.13, so we need to do the opposite. We need to times by 100 to go back to our percentage. And 0.13 times 100 takes us back to 13, or 13%. Now, making all these conversions is really simple, but there are situations where it can become quite complicated. Take, for example, the fraction 3 over 8. How would I convert that to a percentage? It's not over 100, so it's not all that simple. But what I can do is I can easily convert it to a decimal. I can bring up my calculator and just divide it. 3 divide 8 is 0.375. So I'll start by converting it to a decimal, 0.375. It's easy to convert a decimal to a percentage. All I need to do is times it by 100, which just means to move the decimal point twice to the right. This will give me the percentage 37.5%. All right, what's another challenging question? Well, I might have the decimal 0.598, and I might want to convert that to a fraction. What would I do in this situation? Well, you might notice I've got 3 numbers after the decimal point, and that means instead of it being over 100, I need to put it over 1,000. So I'm going to take 598 and I'm going to put it over 1,000. I need 3 zeros because I've got 3 numbers after the decimal point. And I should always simplify my fractions. I'm going to bring up the calculator. 598 ABC 1,000 gives me 299 over 500. So just let the calculator do the simplifying for you. Anyway, I think I've done enough on making conversions here. I think it's time we move on to the example now. Now, not long ago, I said that you can't really use percentages to make calculations. What we usually do is convert our percentage into a decimal or a fraction first, and then make the calculation. When we use the unitary method, we actually can use percentages to make calculations. That's what makes this quite unique. So looking at question A, we are told that a pair of shoes have a regular retail price of $169. How much do they cost after a 20% discount? All right, I'm going to write 2 things down here. I'm going to write the regular retail price. It's $169. Now I want you to think to yourself, what percentage represents this amount? And the percentage I'm thinking of is 100%. What are we talking about when we use this percentage? The percentage 100%. Well, 100% represents all the money. If I said to you, I'm going to give you 100% of my money, that means I'm giving all the money to you. If a shop owner said to you, I want to sell you these shoes, and I want you to give me 100% of the money that these shoes are valued at, well, you'd be giving them $169. There would be no discount. So if we're discounting these shoes by 20%, what are they now worth? Well, they're now valued at 80% of the original price because I've taken 20% off the 100%. And what I'm going to do is I'm going to think to myself, what calculations will I make to go from 100% down to 80%? And I'm going to do it in 2 steps. The first step I'm going to make is I'm going to divide by 100. What happens when I divide 100% by 100? Well, I get the number 1. Why the number 1? Well, you might have noticed that this is called the unitary method. And the word unit means the number 1. So the unitary method involves converting a number to 1 first. I then want to convert this to 80%. How do you convert 1 to 80%? Well, I times by 80. Makes sense, right? So what I'm going to do, whatever I did on the right, I'm going to do on the left. I'm going to take $169, I'm going to divide it by 100 first, and then I'm going to times it by 80, and I'm going to see what I get. So bringing up my calculator, I take 169, I divide it by 100, and then I times this by 80, and I get $135.20. So $135.20. Now $135.20 represents 80% of the original price, which represents a discount of 20%. So I've been able to answer question A. Let's now move on to question B, using the unitary method again. Now I've just noticed it says a denim jack. I meant to write jacket. Anyway, so a denim jacket has been discounted by 40% and is now on sale for $42. What was the price of the jacket before the discount? This is probably more complicated than some people think. This question is a question where the unitary method is the best method to use. We can't use those traditional methods. They don't work very well. What I'm going to do is I'm just going to quickly show you what some people do that's wrong. They quite often go, all right, it's being discounted by 40%, so I need to find what 40% is. And they try to find 40% of $42 because that's the only amount that they can see there is just the $42. But that's an issue because the $42 is not the original amount. It's the amount after it's been put on sale. So what we actually need to do is we need to find 40% of the original amount, and we don't know what that amount is. So there's no way that we can make this calculation. So I'm going to rub that all out. I'm going to show you how to solve this using the unitary method. It's much easier to do it that way. So I'm going to write the amount down. It's $42. And I'm not going to put 100% over here to the right. It's been discounted by 40%, which means it's now 60% of its original value. So I'm going to write 60% over here because $42 represents 60% of the original value. We are asked to find the price of the jacket before the discount. We are asked to find the original value of the jacket. And the percentage that represents that is 100%. We want to find 100% of the original value. So using the unitary method, I convert it to the number 1 first, and then go to the 100%. To do that, I divide 60, because 60% divided 60 takes me to 1, takes me to that unit of 1. And then I times by 100 to reach 100%. And I just do the same to the $42. I divide by 60, and then I times by 100. Bringing up our calculator, 42 divides 60 times 100 will give us 70. So the original price of the denim jacket was $70. Anyway, that concludes our video on example 5. Remember to read the description below for links to workbooklets that relate to this video.